Oh, hello there, and welcome back. Now, I almost removed a lot of the get voxel code there by accident, but I wanted to do something different today. Because the last episode we finished off by rendering actually our basic setup. We can render infinitely amount of voxels right now, but of course it's still the main thread, and of course it's still white and empty and ugly. And that will take a few more episodes in order to get fixed. Now, what I want to do today is actually a bit different as well. Because right now we're calling this, this chunk shit in the world, and calling the render here, but there's no render loop. How are we going to handle a render loop with a player that's walking, loading, unloading chunks, whole that kind of fun stuff? Yeah, let's handle that, shall we? So for that, in order to work, we need some sort of thing that handles our updating. And for this, we're going to use our game manager. And we're going to use a generic way of calling some sort of update method by using an interface. Because we will need more things that will get an update call later on. But we will also get some sort of a tick system, like in Minecraft, every 30 milliseconds? I don't know. There's 30 times a second. No, that's not 30 minutes. It was 30 times a second. A tick is called so something can update in the world. Like any voxel can update, like a state can update or whatever. Like water can flow. And that's happening on a certain amount of time frames. Now, this update that we're going to make right now is just going to be a very basic implementation of a system that we will append on. Now, let's create a simple interfaces directory. And let's make a updatable interface. Let's make this a public interface. Updatable. Let's put this one in generation.interfaces because that's fine. And this one will have one update, one method called update. And that's it. Remove all the unnecessary things because we don't like that. And this updatable, well, we will extend our world to be from type updatable. Because, well, we're an updatable type. And now we need a function called update. This now will not do anything, because this update will, of course, well, normally from our mono behavior will get called every frame, but this world is not a mono behavior. But our game manager is. And we want some sort of way to actually call our custom update methods from this, so we can have control over it. And this is, we'll handle this in our game manager. For now, I don't know if we're going to move this, but it might be. We're going to have a function here, public static void register updatable, and we give it the updatable. And now we of course need to have the using in here, updatable underscore updatable. And this will actually just add it to our instance list of updatable objects. So we have a private list of updatable, and I'm missing another using. The system collections. This one will have an updatable list of updatables. And this is a new list of this thing. Now, in regards to updatable, we're just going to say instance.updatables.add underscore updatable. That's it. No checks whatsoever. It's just going to be added to the system. Now, in this update here, we're going to loop through these updatables. So let's just say for int I equals 0. I is less than updatables.count I++. And then we're going to call updatables i.update. That's it for now. So now we can actually, in the main thread, call this update. Now, this of course is on the main thread, and our other system will have invocations to subthreads as well, because we need to handle rendering, and our ticking system will not be on the main thread. But for now, this updatable will only run on the main thread, because, well, we don't care about the rest yet. If we create a world, we will actually, let's just do this on the world creation right now. So if we do this, we're going to register this active thing to the updatable system. So this will need a rework if we're going to have like multiple world creations, but then we need to deregister as well. So let's say that our game manager dot register updatable dot yes, and then this. I was a little bit stuck there. Let's just do this, and we will not generate this chunk here, not do this, not do this, because now this function will be called. Now, our world, like, we do need something like, where is the player? This is also going to be in our game manager. This one will have a reference to like our main player, our renderer object that will render the data. So this is just going to be a public transform. Let's call it player for now. You can call it anything you want, but this is just being used to get its position and know what we have to render it to. Now that we have this, we can actually go back to our world, and now in our update, we are going to do some magic here. Well, it's not really magic, but we can say our game manager, the player instance, the player position. So let's just save this one real quick. Vector3 player, let's call it position with a lower p. And now we're going to save it as a vector3 int, and let's say this is our chunk position equals new vector3 int, and this is going to be position.x divided by chunk.size, and this will be math.floor_to_int because that's the chunk we're in, and we need to do this for all of our positions because now we're casting our world position to our local chunk position. Now, as you can imagine, we probably will need more often than not get like this piece of code more times. So what I want to be able to do is just ask our chunk class, so chunk.getLocalPosition, and that's it. So let's go to chunk. Let's go above here and let's make a public static vector3 int get local position. And now we pass in a vector3 world position. And now we can still just do this and return this, but then use our underscore world position, world pos as an input. Because now we can actually get it from everywhere we want. So, this is just so we can say chunk.getLocalPosition. It's just an ease of use. So now we can remove it from here and actually say this. So let's do this and then chunk.getLocalPosition with this position. That's a little bit cleaner, right? I mean, it removes the logic from here and it's getting the local position from the chunk from a given world position. Now that we know the chunk position, we need something like a, well, render distance or something. I mean, how else do we know like what to render? And we're going to add this for now here as well. So let's do public int render distance and set this one to, let's say 6. Because we are going to render a bit more chunks than the chunk that we're standing on, of course. So let's do for int x equals minus chunk position. It's just, are we going to do completely squared? We can render complete squares first. We could also do a total distance, but then we have to like do some more things. Let's just do it completely for now. Let's save our distance. So it's int dst equals gameManager.instance.render distance. X equals minus distance, x is less than distance, x plus plus. And let's do this for all the distances. Y equals minus dst, y is less than dst, y plus plus. And int z equals minus dst, z is less than dst, z plus plus. Now there's one thing that we are forgetting right now, and that is that our total distance now will, of course, get bigger than our render distance. So if our like absolute value of the xyz is greater than our distance, we should just continue. So if math.abs x plus math.abs y plus math.abs z is greater than our dst, then we continue. And otherwise we want to render it. So this is just a little check that we're not going to render it in completely square. Now this chunk we want to render. So what we can do is check if this chunk is already there. And if it's already there, we're not going to render anything, right? Because it really doesn't care about this chunk here. So yeah, let's just say that it should actually just render it if it's there, right? Yeah, I think that's fine. So if our chunk, let's just make a new vector3 int for our C position equals new vector3 int, which start off with our chunk position plus x, chunk position dot y plus y, chunk position dot c plus c. And this is our chunk pass. Now let's see if we got this chunks that contains key, chunk pass, we just continue. Because, well, I mean, we just already have it. And if we don't have it, we make a new chunk. Chunk C equals new chunk. Now we do a, well, in our chunk pass. And now we add chunks.add chunk pass C. Now we're never calling this render method, and I also don't want to directly call it here, I think. And also, what happens for the chunks that are, like, not being updated right now? Because if it exists, of course, that's nice. But, like, what if a chunk is out of range, so to say? So we need a way that we can actually detect that a chunk is outside of its radius, without having to loop all over this chunks thing, if that's possible. But I don't think that is possible, and I don't think it's a problem that we have to loop over it. But I do want to make sure that we like save like some sort of state on when a thing is updated and when not, or we just tag it. Because we can just create a list of chunks here of newly generated chunks, and then if it's in there, then it's fine. If it's not, then it's not fine. We have to think about a nice little way to unload chunks. So let's keep that one in mind. Now let's also remember. For now, we can just generate a chunk here. There's one problem with saying c.render here. And that is that this will actually, right now, in the main thread do this, and it might access its neighboring chunks. Which, well, if you can remember, that now the neighbor is not there. So it needs a regenerate after that neighbor is being added. So now it will generate a lot of regenerations here. And that's a bad thing. So in order to prevent that, let's just do a list of chunk, generated chunks, this new list of chunk, and also add this to the generated chunks, add C, and now we do a for each chunk C in generated chunks and say c.render. Easy peasy. And since this generated chunks normally is not that big of a list, it will be fine. And yeah, this will work. But now every frame we loop like 6 times 6 times 6 times through this data here, which is terrible. So what we should do is save our like latest rendered position of the chunks. So let's say private vector3 int latest player loaded chunks, loaded position, something like that. There's new vector3 int. Let's set it to minus. Is there a dot min or something? Dot. Oh, I'm doing it. Vector3 int dot min. No, let's do that. Is it? Oh, okay. Dot. We'll just. Back. The problem with these is that now we'll just create a new one. The reason I do this is that I'm sure that it's not going to be cached like at the same position. Because if this is the same, so if our chunk position equals this position, then we just continue. Or, no, not continue, we return out. And otherwise we set this one to this position, and then the next time it will not render. So if we don't cross a chunk border, it will not do anything here. So I don't want to do this all in updates, so let's call this function private void render chunks, and actually move all of this code inside of there, because this is all chunk rendering thing, and call the render chunks function there. So because it's a bit more clear what it's doing. And this is just a check, like, did we cross a border of a chunk? And if so, we're going to render more chunks. And if not, then we're not going to render chunks. But if so, yep, now we still need to think about the chunks that are outside of our bounds, because that's a pretty important thing. So I think the best way to do this is like keep track of like a simple number of when a chunk has been like marked as I'm still valid. So if we get here, we just say continue now. But what we can do in a chunk is if we are here, we can say like, we can say some sort of an update number. So like a render ID or whatever, because I don't want to calculate the distance and that kind of stuff because that's just heavy. So for now, let's just say it's like a render state. I don't know this name, but I'll explain it a bit better like once we generate it. Because in here, if it exists, it will just update its render state. So now we say chunks, chunk pos dot render state equals some sort of number from here. So we also get a private int chunk render state equals, let's say, 0 to get started, because we really don't, it doesn't matter. Chunk render state. And every time we get here, we're going to increase our chunk render state to be, for example, this. Okay, I had a capital there. Now, if we create a new chunk, we of course need to set our render state to be that as well. Equals current render state. Chunk render state. And of course, we need to return out of here. Continue out of here still. Not return, because that will be terrible. Okay. Because now what we can do is that we still have to loop over like our dictionary. So for each key value pair, factor 3int, comma chunk. Or no, maybe we can just do for each chunk c in chunks.values. If c.render state is not equal to our chunk render state, this means that we need to unload this chunk. But then we need to store another like, so this will be like a private void unload chunks method, which will only be called like after we actually did some things here as well. So let's move it to there. Let's call this one in here, and let's call unload chunks here, because that's a bit nicer. If it's not equal, then it needs to unload it. So we need to store chunk unload chunks is new list of chunk, because we need to remove it from dictionary, which we cannot do it right now. So we're going to add this one to here, but we can already call a c.unload here. It's just that we cannot remove it from the list yet. And we don't have an unload yet, so let's make this just a public method, because we can unload chunks from everywhere we like. It's just that it's not doing anything now. And this has to actually save data to the disk later on, to serialize it, of course. Now, if this is done, then we just do a for each chunk c in unload chunks, and we do a chunks.remove c.position. And now we got our unloading in there as well. If we're here, then there's always something to unload again, because like there's not something that we should not unload. So this is fine. This is fine. This will unload. It's just that we might need to change like our criteria here with this not equal to render state to like wait 2 stages, for example. So our previously like loaded state, it will wait 2 iterations before it will unload. So if you walk back and forth, it will not unload, load, unload, unload the latest data all the time. But that's an optimization that we can make later. So now it should actually handle chunk loading and actually rendering chunks still. So we can test this one out. And keep in mind that we're still doing everything on the main thread. So from now, this will be a bit more obvious since it's still doing a lot of calculations, or it is already doing a lot of calculations. So let's open our general, no, where is this thing? Sequencing, analysis profiler. Let's dock it in there. Let's press play. And let's see if we get an infinite loop or if we're actually doing something. Of course, I didn't assign our player. So let's create a new object, call it player, and assign it to our game manager for now. And that's it. Okay. So now we got a player where it's going to receive its position from. And we got our own like little update loop ready and all set and done. And as you can see, a lot of chunk objects has been generated here. And we're still running on like 100 FPS, and I'm not sure, like, it's not generating anymore, but it looks like it kinda is. It's the editor loop, of course. But as you can see, it did generate a lot of these chunk objects here. And that's the next thing that we're going to optimize. Because if there's nothing to be rendered in here, we do not even need to generate like this game object, right? I mean, we don't care about it. But for now, for this demonstration purpose, it was good. It was very good. So let's go in here and let's go into our chunk renderer class. And let's go down. And if our try index, if our try index equals 0, then we do not have any triangles, and thus we don't need to do anything. Let's just fix it right now. And now we should only see like one little game object being spawned, but we are generating all the chunks. It's just not visible. It's just in data, in memory, and that's it. And now one other thing that we can check, and we can actually do, is our unloading part. Oh, I did it exactly the wrong way around, and I think you were shouting at me already. Nice. That was very, very nice indeed. Let's fix it real quick. Fix that real quick. Let's press play again, and let's see our voxels in action. Well, there's our little voxel cube. And there's only one chunk we can render. Now let's quickly do our unload, because if this is here, we want to store it in here. So let's do private game object, generated object. So our unload method can call an unload in here. And now this GO will be generated object, of course. And we need to set one to shear. And we will go up here, make a public void unload, and then if generated object equals null, we just return out. And otherwise we do a game object.destroy generated objects. So now this unload should be called from our chunk in our unload. So we call this thing our renderer.unload. So now we should actually be able to like see this object get destroyed if we move our player object far enough away from the system, and being generated if we get close enough again. Of course, it will be regenerated now. It will not be read from the disk or whatsoever. It's not serialized. So let's get this player and, well, let's move it away, I would say. And as you can see, it's very laggy. And it should unload this chunk. And I don't know why it's so laggy, but let's keep our profiler open. There we go. We see this lag spike here. It is inside of the player loop, and this is why this is so awesome. It is inside of the update, and there's a lot of garbage collection going on, but there's not a lot more information that I'm seeing right here. So let's go to... Oh, this is pretty interesting. Well, we'll have to do some debugging and resort and checking after this episode. But we will, of course, be resolving these kind of issues, especially like these lag spikes, because, well, this is just not something that you want, of course, because 2.6 MB of like allocation here, that's not good at all. And this self-MS, that's not good either. And it is like all about the GC allocation here, because it is just all in this game manager.update method. But this game manager.update method is only calling this update on like our world system, which then handles this system. And yeah, we do know that we are calling this new chunk on the main thread here. And this new chunk is doing this. And probably doing this is right now the hiccup. I'm actually pretty sure this is the hiccup, because it is still generating all these voxels here. And we can see if this is the hiccup. Let's make it a class, because why not? Because this is even more slow. And let's see what it's going to complain about right now. And let's see what the performance difference is actually. So I think that's what I said in the first episode, or something around there. Oh. Of course, since right now it is a class, we can like assign things and not have it assigned at all. Let's set this one. Oh, no, I'm already saying that wrong. Because it's a class, we have to generate it in our array. So we're not going to like debug this right now in this way, but we will do a comparison about the class versus struct later on. But just believe me, this will be resolved, this lag issue, because we are going to do this multi-threaded. And if we do this multi-threaded, this whole chunk loading will be in a different thread, because we will have a chunk loading thread and we'll have a separated rendering thread as well. We're not going to like use 10 different threads for rendering. We're just going to use one separated thread for rendering and be happy. Okay, well, that's it for today. So I hope you enjoyed. And well, the next time we're going to set up some multi-threading awesomeness. So hopefully I'll see you then.